Welcome back to Environmental Economics for the fifth lecture in this series. Today we will look into the feasibility and desirability of economic growth with a discussion of some ecological economics and happiness economics literature. Last week we talked about valuation methods and estimates for the global value of ecosystem services. The increased awareness of the loss of ecosystem services over the past decades has inspired post-growth perspectives in economics that explore alternatives to growth. We will start today with Hickel and Kallis, who ask whether green growth is possible, where I elaborate on the environmental Kuznets curve and Jevons paradox. Next, we will explore whether economic growth brings happiness. Here, I will explain the Easterlin's paradox and highlight a few other observations from the happiness review by McCarran. We will close today with an overview of Daly's steady-state economics and some other post-growth perspectives. In Is Green Growth Possible?, Hickel and Kallis observe that a green growth policy objective has become embraced by international institutions such as the OECD, the United Nations Environment Programme and the World Bank. The hope is that economic growth can be decoupled from resource consumption, greenhouse gas emissions or other impacts. This idea that economic growth can be beneficial to the environment became best known as the environmental Kuznets curve hypothesis. When talking about the environmental Kuznets curve, it makes some sense to start with its prequel, the Kuznets curve. The Kuznets curve, in short, proposed that inequality would follow an inverse U-shaped path with respect to growing income per capita. Kuznets was still cautious about the value of this hypothesis when he remarked, "The paper is perhaps 5% empirical information and 95% speculation, some of it possibly tainted by wishful thinking." And indeed, for the first years following Kuznets' his 1955 publication, inequality dropped with income growth for high-income countries. Here we see a graph taken from Piketty's Capital in the 21st Century, where we see that the income share of the richest 1% is decreasing over time for the US, Britain, Canada and Australia until the 1970s. In 1971, the Nobel Committee awarded the prize in economics to Simon Kuznets, yet the curve named after him started to crumble soon after he received the prize. After the 70s, economic growth was accompanied by rising inequality. The OECD recently estimates that global inequalities have never been as stark. Reductions of inequality are not an automatic benefit of economic growth. The promise that the rising tide floats all boats only seems to hold guarantees for the yachts. And so the Kuznets curve indeed turned out to be an impressive exercise in wishful thinking. In the early 90s, the idea emerged of an environmental Kuznets curve. Much like the original Kuznets curve, the environmental Kuznets curve hypothesis has pollution rise with income at first until some turning point income level from which pollution starts to fall with further economic growth. The hypothesis was popularized by the World Bank World Development Report in 1992. The report motivated that the view that greater economic activity inevitably hurts the environment is based on static assumptions about technology, taste, and environment investments. The report provided the following intuition for the hypothesis. At first, economic growth puts pressure on the environment through a scale effect. Without changes to the structure of the economy or available technologies, pollution grows proportional with economic activity. However, at some point, higher income levels, further growth starts to raise both the demand for improvements in environmental quality and investment opportunities to do so. A first glance at some pollution data suggests that there may be an environmental Kuznets curve mechanism at play. Here we see a figure from Gurdjieff et al. With the concentrations of total suspended particle concentrations in some megacities together with the World Health Organization guideline. Although the paper is from 2008, the World Health Organization estimates that today about 9 out of 10 people globally breathe polluted air and that PM pollution claims about 7 million lives per year globally. This observation of decreasing air pollution for higher income megacities may seem in line with the idea of an environmental Kuznets curve, but does the hypothesis withstand more thorough empirical scrutiny? Is it really the case that economic growth is a friend of the environment? Shafik and Bantyopadhyay studied 10 different pollutants. From these 10 pollutants, only 2 air pollutants showed a path that seems in line with the environmental Kuznets curve hypothesis: sulfur dioxide and suspended particles, both pollutants of local air quality that affect the human health. 2 pollutants decreased continuously with income: urban sanitation and water pollution, and 2 others increased continuously with income over the sample period: carbon emissions and municipal waste, while the remaining 4 pollutants showed paths that seemed unrelated to income. This study by Shafik and Bantyopadhyay reminds us that not all pollutants are alike. It also illustrates a first tricky aspect of the environmental Kuznets curve hypothesis, namely, in addition to the figures in the middle, also the continuously decreasing and continuously increasing impacts with growing income can be consistent with the environmental Kuznets curve, as it is possible that we find ourselves after or before the turning point of impact. In addition to the possibility that turning points for income differ by pollutant, there are various other difficulties to keep in mind when evaluating environmental Kuznets curve literature. Perhaps most importantly is that suggestive evidence in favor of an environmental Kuznets curve from cross-country comparisons can easily be the result of competing hypotheses such as the not in my backyard hypothesis, pollution haven hypothesis, or race to the bottom hypothesis, in which high income regions export polluting activities to low income regions. Put differently, the observation of an inverse U relationship between pollution and economic development could easily be the result of trade rather than a reduction of pollution through innovation, investment, or legislation. This figure by Suri and Chapman shows how imports and exports of manufactured goods have grown or decreased from the early 70s to the late 80s. The idea here is that manufacturing is often one of the more polluting industries, and we see that exports of manufactured goods have increased disproportionately in countries with lower average incomes such as Thailand, Malaysia, Brazil, or Mexico. Complications of trade aside, the environmental Kuznets curve suffers from another challenge, namely that in its motivation it gathers together a range of possible positive influences on the environment such as education, legislation, policy, and technological development, all under the same header saying brought to you by economic growth. When attempting to isolate the effects of economic growth, say absence of trade, a falling level of some pollutant over time with simultaneously rising incomes may still not be sufficient evidence of an environmental Kuznets curve. Harbaugh et al. Explain this point. This may be counterintuitive. Sulfur dioxide concentrations in Canada and the United States have declined over time at ever decreasing rates. After detrending the data with the time function, pollution appears to increase as a function of GDP. By 2004, there were enough articles exploring the environmental Kuznets curve relationship to warrant at least 2 literature reviews. Focusing mostly on sulfur dioxide emissions, Stern concludes, "It seems unlikely that the environmental Kuznets curve is an adequate model of emissions or concentrations. I concur with Copeland and Taylor, who state that our review of both the theoretical and empirical work on the environmental Kuznets curve leads us to be skeptical about the existence of a simple and predictable relationship between pollution and per capita income." More recently, in a meta-analysis of 547 estimates from 96 different studies focusing on deforestation, Schumert et al. Find that the more recent the year of publication is, the more the likelihood of having an environmental Kuznets curve declines. Hickel and Kallis describe how the promise of green growth depends on technological progress. For global resource use, we have observed relative decoupling, where impact increases less fast than the economy, yet still increases. Green growth requires absolute decoupling, where impacts decrease with growth. Paris Agreement consistent green growth would require gains in efficiency that are manifold the historical rates. Worse yet, scenarios that take rebound effects of increased efficiency into account show that it seems virtually impossible to reconcile sustained economic growth with achieving Paris goals. This rebound effect was first identified by Jevons. In the coal question of 1865, William Stanley Jevons asked how long the UK could keep up its consumption before running out of coal. He described an exponential increase in Britain's coal consumption. Some authors at the time suggested that technological improvements in efficiency would prevent UK mines from running out. However, Jevons contested the idea that technological advances lead to reductions in the consumption of resources. It is wholly a confusion of ideas to suppose that the economical use of fuel is equivalent to a diminished consumption. The very contrary is the truth. To evaluate Jevons' hypothesis with respect to environmental impacts, it can be useful to split up our impact and to express our collective impact with the IPAT identity, where I refers to some environmental impact, let's say carbon dioxide equivalent emissions, P to people, A to affluence, say in dollars per person, and T to technology expressed in environmental impact per dollar or carbon dioxide equivalent emissions per dollar. To answer whether technological advance leads to a reduction in impact, much of the literature considers technological advance as expressed by engineering savings. Hickel and Kallis use the IPAT identity to argue that long-term limits to efficiency gains can only mean that sustained growing affluence will at some point unavoidably lead to growing impacts. But why wouldn't technological advance give resource savings? Like the World Bank's argument for the environmental Kuznets curve, Jevons challenged static assumptions about behavior. He described three mechanisms through which consumption would increase. First, improved efficiency of resource use or extraction raises the profitability, which attracts investments, leading to an expansion of the industry. Second, the improved efficiency may push down costs far enough to drive invention or open opportunities for new uses to become viable, raising consumption in new industries. And third, the improved efficiency makes use cheaper, which can in turn boost demand. For example, more fuel-efficient cars do not only enable people to use less fuel for the same distance, it also enables them to drive more. Jevons' paradox put forward the idea that resource conserved through more efficient use will be consumed due to growth in use. Whether technological advances decrease resource consumption or, as Jevons expected, increase consumption is an empirical question. After our review of the environmental Kuznets curve, it should not come as a surprise that the answer is it depends. It depends on the time period and technology considered. But as Alcott puts it slightly more informative, empirically measured rebounds range from less than 1% to several 100%, but never 0 or less than 1. Here, rebounds refer to the increased resource consumption as compared to what would be expected based on prior consumption minus engineering savings, so that rebounds between 1% and 100% are partial rebounds, but still give resource savings, just not as much as based on engineering savings alone. and the Jevons paradox occurs for rebounds of over 100%. Jevons paradox is also informative when it comes to how much we can expect from climate policies aimed at improving efficiency. As Alcott puts it, if Jevons is right, then efficiency policies are simply counterproductive. Even taxes on fuel or carbon dioxide will be compensated by efficiency increases. And moreover, they face the problem that tax revenue also gets spent on material and energy. Hickel and Kallis show that the only periods during which global greenhouse gas emissions decrease coincided with global recessions. From our review of the environmental Kuznets curve literature, we have seen that some pollutants seem to exhibit such an inverse U relation. However, an automatic environmental Kuznets curve is unlikely, and in the case of greenhouse gases, it is simply unrealistic to expect that economic growth will help to stay within acceptable global warming. Even if we were to believe that spectacular efficiency improvements are possible, technological advance alone may backfire for resource consumption in the aggregate, as we have just learned from Jevons. Alcott concludes that, politically unfashionable though they may be, Jevons himself denied that the consumption of coal can be kept down in our free system of industry. Ecological economics should once again take resource rationing seriously. If economic growth and technological developments do not help to overcome the challenges of climate change, it seems clear that we will have to rely on more direct policy.